Hey everyone, welcome back to Jetson AI Labs. As always, I have our co-hosts here, Dana and Jim from
Hello.
JetsonHacks. Hey guys,
Hello.
good to have you all back. We were off a month there for GTC, but we're back. This month's guest is Benjamin McDonnell from the Hacksmith, and he's a lot of awesome stuff here to show us today. The Hacksmith channel, if you're not familiar, they take a lot of cool gadgets and gizmos from science fiction movies and bring them to life in reality, which is so cool to see. But before we bring Ben on the show, we're just going to overview some quick news items here, what we have going on. So Jim, Dana, do you have anything you want to talk about, anything new in your neck of the woods?
Well, we don't have anything new other than what we did with GTC, which I think we're going to talk about also. So maybe that's what we want to talk about. I don't have anything otherwise new. What about you, Jim?
I don't have anything really new, but I was really curious about. So let me kind of take a walk back here. So I had been involved with GTC as, an outside participant for the last probably been 5 or 6 years. And one of the things that most folks don't see is how much work goes into kind of behind the scenes of putting the show together. And I've seen it, and it's kind of scary because you don't really get this view of what it takes to put on that kind of show. But with this year, it was like 2,000 talks or something like that. And I was curious and I'd like both kind of Dusty and Dana to kind of give me your viewpoint of, what's it take to put on a show like that, or what were some of the important parts that you saw that, some folks might have missed, or even something that's not Jetson related, something you found interesting in some of the talks, just because the scope is so large that you just can't wrap your head around, 2,000 different talks.
Right. Well, I guess I'll start with that, because from the DLI point of view, so DLI is kind of a subset within NVIDIA for training. And we have a lot of all-day courses that we traditionally put on at GTCs. In fact, Jim and I built a course on robots that we put together a few years ago when we were live and in person. And that, as you recall, involved bringing in all the robots, testing everything, all the setup. There was IT people all over the place, lining up everything. So in the last year, with all the COVID restrictions, we had to quickly switch to digital last year. And it was kind of a scramble. And then this year, of course, we knew it was coming. So in one way, it's not as fun to be right there with all the people as we did before, where you can walk around and talk to people. But on the other hand, it has given us some other opportunities. And it's been interesting to see that migration from in-person to digital. One of the things for DLI is that with these workshops that we generally put on in one day, we put on for a week, and we did it around the clock. They were actually delivered in Taiwan. They were delivered in Chinese for Taiwan audiences. They were delivered for Indian audiences. They were delivered in Europe, the time zone for Europe. They were delivered also in Korean. And this happened around the clock with some of our regular workshops, such as CUDA and Introduction, Fundamentals of Deep Learning and Recommender Systems and Natural Language Processing courses. So this has been a big change. It's doing everything online and trying to make people feel engaged online. But on the other hand, we also got to reach more people, I think. So that's been an interesting evolution.
Yeah, absolutely. And I feel the same way. We've definitely reached even maybe an order of magnitude more people, because it was all online. And like Dana said, it was 24/7. And it was actually, GTC was actually 2 weeks this year. There was the first week, had a lot of the live sessions, and then the second week we called the after party and had even more live and on-demand sessions. And Dana and I had done a bunch of those together, and it was really great just to interact with people. And my favorite is always doing the Q&A, and just like we do on this show, that was really the impetus for this Jetson AI Labs live stream, is just to get to interact with you guys out there. But I think when we found a lot of the sessions that had the most interactiveness, and most people won over a lot of the intro to AI sessions that we did, and people looking to get started. So there's definitely a lot of folks out there that are interested to take their first steps in getting involved with machine learning and computer vision. And really, we like to always make it easier to get started for folks that are new to that. And so you don't need a PhD in machine learning or computer science. And it's just become a lot easier than it was even 5 years ago when I first started, because not that long ago I was in everybody else's shoes, and didn't know about deep learning and all of that stuff myself even. And I would say the other big benefit of having this all online and all digital was that there's now this archive of all these sessions. Every session that was online there, all 2,000 of them are now online for viewing on demand anytime that you like. So obviously during the week of, nobody can go to all of those sessions, but now you can go and view them. And we actually have this on-demand site now that houses all them. Let me show that to you here. So in case you didn't get a chance to join GTC, or you're just too busy to view everything, if you just Google NVIDIA GTC, that'll take you to the landing page. And then you can press the Browse Content button here or in the upper right-hand corner, and it'll take you to this on-demand page, which essentially you can find all of the talks here. Here's the autonomous vehicles and robotics track. This is what all the Jetson stuff is under here, so you can find all of those sessions. But really anything that you're interested in, I enjoyed in my downtime at GTC going off into new areas that I hadn't done before and really diving deep into this. And everybody from like top machine learning researchers to industry and a lot of NVIDIA folks presented at this session, including our guest today, Ben. He was involved in a couple of community sessions that we did. So those went really well. I guess, Jim, does that answer your question?
Yeah, I think that's one thing I found is it's extremely easy to go down the rabbit holes once you started looking at that. So like one of the things was over the last year or so, I've been really interested in two subject areas. One is virtual environments like they use in television broadcasting. The Mandalorian, Star Wars is probably the most famous. And kind of motion control is the second area. But they had some pretty good talks on the virtual environments. It's, again, that's another thing that's hard to get your head around is as far as scope-wise, from a technical perspective. I don't care about a puppet, going on and on too much. But when you talk about having a virtual stage where you have 1,300 monitors around you, running off of 7 different computers, and you get kind of camera full in camera type of special effects on Unreal Engine, all perspective mapped and everything. That's a really interesting technical problem, and something that you couldn't have done even 5 years ago. So it's really, but every single place you look there, it's like that. So if you go into the medical field, you start looking through all the talks that they're giving, and you don't understand half of what they're saying, but it's really interesting, right? So
yes, there's more than you have time to do.
Yeah, and especially the autonomous vehicles and stuff, things that I'm interested in. That's really fun to listen. And the thing that I noticed, it's a lot different than a talk, because it's much more prepared as they walk through the material. Usually the talks are 15 minutes of who I am, and then 10 minutes of useless questions at the end of it.
So they're pre-recorded. Some of them were pre-recorded.
Some of them were. Mm-hmm. And so the ones I watched, most of them were pre-recorded, but there were also kind of in-person events like
we had.
Yeah.
Yeah. One interesting challenge of running such a large digital event is all the infrastructure required to stream to, hundreds of thousands of people simultaneously on live and handle all the live questions and all of that. So it was certainly interesting how it's done, and we learned a lot from it and hope to continue to benefit from that into the future.
Yeah, so let me ask you one more question. So GTC in the future, what do y'all think that's going to be? Just the 30-second overview.
Even if people are able to see each other in person, there will always be a digital part of it. Because I think one of the things that Dusty just said about the demand later, that's been huge. You know, it's huge that information is all right there at your fingertips going forward, and that drives a lot more engagement for more developers to go back and say, well, I didn't get to go to the conference, or now I'm interested in such and such, and I didn't even think about it then. They can go back and they can watch the deliveries. And so it's really reaches just so many more people that even though in person is great and I miss it, we will always have the digital now that we've tried it. That there will always be a part of it, in my opinion.
Cool.
Yeah, I think the expo floor was the maybe only thing I'm missing. Maybe we can find some digital twin of that. But I always enjoy that part of the.
Yeah, me too. I like being there.
Yeah, because like meeting all you guys out there on the stream who's able to come, and that's super valuable to us. All right, so before we get too far deep into this here, let's bring on Ben. He's this week's guest. He's from Ontario, Canada, and is with the Hacksmith channel. Hi, Ben. Thanks for joining us.
Hey, Ben.
So yeah, as we mentioned, Ben, just to give you a quick intro here, Ben does a lot of the research and development for the Hacksmith channel, and you bring a lot of these really interesting sci-fi devices to life. And I guess instead of me explaining who the Hacksmith is, would you like to give a quick overview of your channel and how you got involved and everything?
Yeah, for sure. So here at the Hacksmith, we take ideas from movies, TV shows, video games, comics, and make real working prototypes. So some of our more popular ones would be our lightsaber. We've made a couple working lightsabers, both plasma-based or solid core. They're technically proto-sabers, but they're recognizable as lightsabers. Other big ones is our electromagnetic America shield. That's another big video of ours. It was a Captain America shield with an electromagnetic bracer, so you could retract the shield and grab it up out of the air, stick it to your arm. That was well before my time, but it's a big project of ours. And then kind of what I do is, as Dusty said, I do a lot of the R&D, but often I'm kind of in the software and electronics side. So almost any project, or a lot of our projects that have electronics in them, I've helped in some way, be it developing the whole electronic system myself, be it consulting on some components, be it writing the code for it. So I often help with a lot of that respective things here. Yeah.
Cool. Awesome. And how long have you been there?
So in a variety of capacities, I've been here for the past 4 years. I've been on and off in summers, part-time in the school year, so 4 years. I've been working full-time for the past year at this point. I'm on a co-op term, so quite a while.
Wow. Cool. Okay. And I think most recently, so you've done a couple projects that have used Jetson now, but most recently you've built this Jedi training drone, I believe.
Yeah.
And maybe you could. Oh, there it is, right there.
Oh wow.
Got it. So it's a standard racing drone almost. If you look at it from the top, it looks kind of like a racing drone. Took some components, and then we thought, so we have a lightsaber. We have a bunch of other Star Wars stuff. Well, we need a way to train. We need a way for James to learn how to master the lightsaber. And sure, we can shoot stuff at him. That's fun. But that takes a lot of time, and employees' time are valuable. So why not develop something that'll do it for us? So we took, it was a modified Nerf gun, put it on the bottom, and a Jetson, and a bunch of other stuff that'll go over, and it will find a person and shoot Nerf balls at them.
So it's kind of like that scene from, I think it was in New Hope, where Luke is aboard the Falcon and there's those little balls on him and he has the mask on and, you know, they're shooting laser beams at him. So I take it that was the inspiration.
That was definitely inspiration.
Awesome. Awesome. And So that thing has a Jetson on there, is that right?
It does. It's kind of buried inside because it's hard to package stuff. Up kind of on the bottom, it's a Jetson Xavier NX.
Nice.
So,
And is that thing like, did you build that basically from the ground up, that whole drone?
yeah, so the entire blaster mechanism is all 3D printed based off of a Nerf mechanism. The entire frame is water jet carbon fiber. All the standoffs and all the mounting assemblies were either machined or 3D printed by us. So nobody sells a system that does this, so we got to make our own.
Yeah, maybe you could be the ones to sell it. It's a nice piece of kit. And I think I see, is that like an, what is that LiDAR unit? I have one of those on the bottom,
So,
like a rangefinder.
Yeah, that's the Garmin LiDAR Lite V3, I think it is.
Oh, right, the LiDAR Lite. Yeah, those are nice.
Yeah, it uses I2C to communicate, which is really nice because the Jetson has I2C. It's a little bit bigger than we wanted, but it's not heavy, and there was enough space for it, so it's the one we had in stock, so we used it.
Cool. I think I see a Z there. I assume that's for the vision.
It's a Z2, and that's what actually does the computer vision. Because we make these projects to make videos out of them, we need to be able to turn them out relatively quickly. This project took about 4 months of total development time, which is longer than normal. But the reason why it was able to be so quick for something as in-depth as this is we use the Z and all their libraries to do all of our computer vision. And that allowed us to save a lot of development time and get a system that just worked out of the box. And that's one of the reasons why we picked the Jetson, because we knew that it was a platform that had all the interfaces that we want and had the external support to allow us to interface with the hardware that we needed.
Awesome. And so is there a flight controller on this thing as well?
There is. So up in this center stack, it's a standard drone flight controller, and then a pair of 4-in-1 ESCs, because we needed 6 motors, and 4-in-1 ESCs are fairly easy. So it's the actual, the electronic speed controllers, the motor controllers that convert the flight signal, so the motor powers, into the high current required to run the motors themselves.
Gotcha. Okay. So you have video comes in from the Z to the Jetson. Use the Z SDK to. Are you? I assume so. You need to track the Jedi, and then does it find any obstacles, or what type of processing pipeline do you have? And then what's the output to the motor controller?
So we did look at trying to do object detection. And with the Z camera, it really wouldn't be that hard. But we were running out of time, so we decided to skip that out. We have a big enough warehouse space that we can not use object detection and be okay with it. So we're just using the Z to find the coordinate, because the Z, through their SDK directly, it allows us to find people or I think cars in the image. Just go to the box. And then it gives us a full 3D coordinate of where they are relative to the camera. So we kind of process that, figure out where we want it to be. So for early testing, it means very, very far away. And then as we kind of became more confident, we could bring it a little bit closer to the person, because you don't want it to be that far from the person for training. So we were able to use fairly simple code to convert the coordinates coming out of the Z into the commands going to the flight controller using it would have just been fairly simple PIDs for that.
What happens if somebody's training and then somebody else walks into the room?
So the way the Z camera works is every object that it detects is given an ID. So if there's no one in the image, what it does is it finds the very first person, and then it remembers that ID and says, that is the person I want to follow. If it loses that person, it tries to refine them. And if it can't, it'll just pick the next person in the image background, and it'll just ignore you because it only cares about the person that started training with it.
That's cool, though. So there is some temporal tracking of the individual.
Yeah.
Awesome.
And that's all built into their system. We didn't have to program any of that.
The Z SDK is really nice, and it's a powerful camera system that they have. So a couple questions from the audience that we have here, Ben.
For sure.
Somebody's asking, what battery are you using to power that whole thing?
So I don't have it with me, but it's a little 6-cell lithium battery. So it's a 24-volt roughly battery. It's a 1500 milliamp hour and then 100C, so it's rated to put out 150 amps continuous.
What kind of flight?
Sorry?
What kind of flight time do you get out of that?
We found somewhere in the 4 to 5 minute range.
Nice. Yeah.
Which is reasonable for a drone at this size.
Yeah.
And that's fairly calm flight too.
Yeah. At that point, I think it's mostly the motors on the thing that are sucking most of the juice as opposed to the electronics. And then there's another question. How much does the whole thing weigh?
A lot, more than it should.
The heavy boy.
I haven't weighed it. I'm going to guess somewhere around 1.2 kilograms. So
okay. Yeah.
What's that? 3 pounds almost?
Yeah, so 5-minute flight time is actually pretty good for that.
It is. It's a bigger battery than you normally would run on a drone of this size, but it's what we needed to get the flight time that we wanted and to be able to supply the current that it needs.
Yeah. So there's some people on the channel that they want to see a video of it working. Is that something you could show you maybe from your YouTube channel?
I do. I can find a video for sure. Just give me 1 minute. So this is from our final test video that we put out.
Water.
This is the scene. James has just been training, running around the shop, trying to practice using the force, and all of a sudden, the drone shows up. He needs a lightsaber. So there it is, flying around, kind of tracking the target, shooting at random intervals, moving around him. And yeah, it worked fairly well.
All right, this is pretty fun, but we didn't make the world.
We have some more footage of it later, but that was just a whole standard plastic off-the-shelf lightsaber, and we can do better than that.
All right, let's try this again.
We decided we needed to use our plasma-based lightsaber, which in the end doesn't work very well since the plasma isn't flying very fast and the balls aren't in it for that long. They just kind of fly right through it. So it does work. It flies. It's a lot of fun.
So we could probably do a whole hour just on those lightsabers. But so it struck me, there's also behavior in that drone where it like moves around and, you know, it's a moving target, which is kind of different than other tracking systems you might want to do, which is like just get a stationary fix. Like the whole point of this drone is to move around, so it's more challenging. What type of, how did you code that into the behavior of it?
So that was actually a lot easier than we expected. Since we had the code to kind of hold it in a position relative to the person, all that we did was on the drone, when it was within the range and it knew it had ammo and it was in its firing state, added some yaw command to it. So that's the rotation about this axis. So we just fed in, it was like 5% of yaw command, and the drone itself just tried to keep the person in the center at the fixed distance. So we decoupled the yaw from the controller, from the Jetson, and just told it, just give it 5% power and let the rest of the maneuvering handle it. And then that just kind of moved it around.
That's what gives it the wobble.
Yeah.
Very interesting.
And then at random points, we would change directions, send it back the other way, fire, not fire, fire 2 balls, fire 1 ball.
How much ammo does it hold?
In this massive magazine, it's only 10 balls. So not a whole lot, but
That's still pretty cool. And is it just, does it just fire those off at random intervals, or is there a little servo in there that controls that, or actuator?
Yeah, so we actually have 2 more. I can't really see that very well. Give me a minute. So up in there, we have 2 more of that. I don't know if this is really working. We have 2 more of the same drone motors. that actually spin up the balls to fire them. And then
Oh.
off to the side, we have just a standard RC servo that actuates the mechanism to fire them. So
Wow.
it's just,
And that's all custom too.
it's all custom.
Wow.
And the balls come at the front. Just trying to get one out.
How long did it take you just to develop that part?
So Sophie, one of our co-ops, did a lot of the hardware development on that. And that was probably a good month of trial and error and print apart and try it and then figure out how to mount it, make another iteration.
It looks really nice.
Was that the hardest part to develop, or was there some other part that was the bigger challenge?
The tuning was quite challenging, just because the flight times are so short and it is quite loud when it's flying. Tuning all the PIDs and setting all the gains properly, that was challenging at points, but mechanically it went together fairly easily. I just kind of started throwing everything together in an assembly. Look, well, I know the motors needed to go in a certain position. I knew the camera needed to go somewhere where it wouldn't be interfering with the motors. We knew we wanted to put the weight under it to have a lower center of gravity. So we put the blaster underneath it and then just kind of started to fill in the gaps where we could. So we have to put a frame piece here. We have to put these standoffs and just kind of built it up.
It's interesting because like a lot of times people like myself will get a drone kit, right? And it's kind of already flown before, and yours is bespoke, completely custom. What were the first flights like? Was it tethered or just hover for a little bit?
So actually, I think I have test flights in the video, but I'll go take a look for that. But the way it started off was just building it kind of a test frame, mounting the electronics to it, following following a standard drone build kit, as you said. We followed that through, flew it around, tested it, made sure it worked, and then added some weight onto it to see if it worked. This is before we had any of the smarts on it. Make sure it could carry the weight, make sure it had enough flight time for what we wanted with the motors and props that we had chosen. And then after that, it was start adding more to it. We started by adding like the Jetson, got that mounted, got that all hooked into the power system. And then as we started to add more, we did a lot of the tuning, like just with the drone sitting on a bench, no motors on, just checking that the outputs are sane, me moving around in front of it to see where it wanted to correct, to make sure it was correcting in the right directions. And then we did some flights where the Jetson was fully mounted on it with the camera running the final code, but we were just logging the outputs and then compared to the outputs that I was feeding the drone, so still flying manually. And then I was trying to kind of do the maneuvers that I expected it would, and then see if the outputs that it was outputting were somewhat in line with my outputs, just to, again, make sure that we're not out by an order of magnitude on our gains. Make sure it's not going to decide to fly into the wall at full speed or into a person or something else. So just testing the system on the bench and then in the air. And then it was the first test flight. I remember very distinctly the first test flight we did where we actually gave it the controls. And it was actually on our remote, there's something called a trainer switch. And what it's designed for is you can plug another person's radio into the back of yours. So if you're training someone else how to fly an RC plane or a drone, you can hold this switch. It's a momentary switch that gives them control. And then as soon as you let go of the momentary switch, you take control back. So we actually used the trainer switch when we were tuning it. And just you pull the switch, it goes into autonomous mode, you let out the switch and it backs off. So it's just, you get it into the correct position, you pull the trainer switch, see what it does, make sure it doesn't move when it shouldn't, and then you kind of take back control, put it in another position, pull the trainer switch, see if it moves into where it needs to, or hovers to the correct height. So there's a lot of stepping it up, because this thing can be very scary.
I bet. So how did you go about, could you give us kind of a scope of the types of projects that you can build in-house, the kind of materials you use? And so it looked like the frame was carbon fiber mixed with 3D printed materials? How much do you do kind of in-house? Do you have, what type of machine tools do you have and stuff like that?
So we have almost anything we could need. For this drone, for example, the carbon fiber, we bought just sheets of carbon fiber, full finished carbon fiber with the resin, solid sheets. Designed the frame, put the sheets in our water jet cutter, and cut the sheets out to get the drone shape that we wanted. So that was fairly simple. We didn't have to CNC machine anything for this, but if we need to, we have 3 different CNC machines, 2 mills and a lathe. One of them is a 4-axis machine,
Wow.
which is quite nice. We have a plasma table, a CNC plasma table for like 2-inch thick steel. And then we got a laser cutter, but it was actually after this project that lets us do very thin stainless and steel and even titanium and aluminum, all very accurately, just laser cut incredibly quickly. So we got the laser after this project because I feel like we would have used the laser more for this if we had it. But we're at the point where we can almost make anything that we want in-house.
Interesting.
We outsource, actually. So we made a custom Jetson hat, a PCB, right here for it. And PCBs are something that we do outsource for now because PCB manufacturing is expensive. But we have all the design resources in-house. We are sponsored by LTM Design. So we have the software, we have the experts. We can make these really nice, professional-looking PCBs fairly quickly.
So what does that hat do?
It kind of breaks out all of our signals into nice connectors. So we have just the connectors that we need with all the correct pins. It does some very basic voltage regulation. And then it's about it.
That's super cool. No, I know one of the other guys here on the stream, Raffaello, he specializes in making his own little boards like that too, and it always really adds a lot to the project. So Ben, I know you've done a lot of the software for this, but did you also do electronic engineering design of that board too?
So this board in particular, I didn't do. I handed it off to one of our professionals for this. I did help with prototyping the circuits. Like we obviously, before you make a PCB, you assemble them on a breadboard or something, a perforated circuit board. So I did do a lot of that design, speccing out all that we needed, and then I kind of passed it off to our in-house professional for these boards. But I have done basic board design as well.
Wow. How many people work there?
So as of right now, I think our count is about 17.
Wow. And how big's your facility?
It's a 13,000 square foot facility.
Wow.
So fairly large.
Makes you really appreciate it. You're flicking through YouTube and like, wow, that's cool. But like, there's so much that goes into that. So can you give us a little run? We talked a lot about the R&D of how you built this, how you made it. Can you give us a little bit of rundown of behind the scenes of like actually filming this? And obviously your production value is extremely high on these videos.
Yeah, so like from the very beginning, we have I'm sure a lot of YouTube channels do stuff similar to us we have a giant spreadsheet of project ideas. And we'll go through them, we'll estimate costs. So we say this one, we think it's going to take $2,000. We think it's going to take $10,000. Whatever, pick a number, estimate the cost, and then estimate the amount of time it takes to make it. And then we kind of, as we need projects, we can pull from there. And this was one we've known we want to do it for a while. And kind of once I'd gained some experience with the Jetson Xavier, or with the Jetson platform, because I'd never really used Jetsons up until the Predator helmet project that we did, which I think we can talk about at some point. We kind of said, hey, I think we can do this now. And we were getting a co-op in who had some mechanical experience, so she was able to help with it. So we pulled that one out and started it. And we kind of had a meeting beforehand saying, these are the end goals for the project. We want it to be able to do this and this and this. And we need to be able to film it doing those things. And then we start the research and get it to a point where we've made a couple tests, we know the project is going to work, and then we would book what we call a creative meeting, where we sit down generally with James and Ian, so the owners of the company. We sit down with a video production manager. Generally, our engineering manager would come in, and then the engineers that were involved with the project. Oh yeah, and then the cinematographer who's actually going to be filming and editing the video. So we book a big meeting with everyone.
You have like a real structure to this. It's not just a bunch of dudes running around with, it's just like NVIDIA, engineering managers, meetings, Now, if you have a Jira and Jira tickets, then I'd say maybe you take it a little too far. But I think that's cool. So
we do have Trello tasks, but
okay. You're agile. You're agile. So you said it took you 4 months to do, which is pretty long time, but it is like an amazing device. And doing any custom robot from the ground up that's autonomous, takes a while. And it is a special moment when you flip on the autonomous and it comes to life in a sense, But so what was your initial estimate for how long it would take you to do?
I think it was about a month and a half.
A month, yeah. So I always go by the multiply by 3 rule. Whatever you think it's going to take, multiply by 3, and it's like pretty accurate.
You start with what you think the unreasonable estimate of amount of time, and then you multiply it by 3. Right.
The 99% probability number.
It can't take more than 6 weeks, and then you multiply by 3 weeks by 3.
Yeah.
We have a couple questions to catch up on here. There's a couple questions like, what flight controller was it? I forget if you mentioned, and what protocol are you using between the Jetson and the flight controller to communicate?
So the flight controller, it's a T-motor flight. Fairly standard system. I don't know, all drone flight controllers that you can buy nowadays are basically the same. They all run almost the same firmware. It's called Betaflight. It's been developed for years at this point. And all racing drones are run on basically the same firmware. They all run on, it's all the STM32 series of processors. It's either the F3, the F4, or the F7. This is the F4 one, so kind of the middle of the road processor. And they're all basically the same. At the end of the day, it's features, whether you're getting stuff like an on-screen display, if you're getting certain inverters, a variety of weird features that you can get. But this is it came with a nice 4-in-1 speed controller that we liked. It was one cable to plug them in together to just save time, and it wasn't not anything fancy. But then for the communication, since we also up in here have a standard receiver because we wanted to still control it with a standard drone remote control, that uses a protocol called SBus, and it's a serial-based protocol. It's a bit weird. It's a 10 or 100,000 baud, very unstandard. 1 parity bit. I don't quite remember the details for it, but it's series of 16 11-bit numbers that represent all 16 channels. So you just do all the bit shifting around, and then you have all the channel values that you need. So using a Raspberry Pi library that we found, we were able to just lightly port it over to the Jetson. It ran on C++. We wanted to write our code in Python, so we had to port it between there, which wasn't that bad. It was actually our co-op Sophie that did a lot of that work. So I put the SBus into the Jetson, and then we do our manipulation and output the SBus back to the flight controller. So the flight controller, as far as it's aware, is just talking to a normal receiver.
So yeah, speaking of the code, you mentioned that you did this all in Python, and were there any challenges you encountered there with making it fully real time, or since you're using the Z SDK underneath, and a lot of this is already C++, was any lessons learned or takeaways from that?
So a lot of the boilerplate code was written by our co-op Sophie. I kind of came in, added the more complex functionality like the PIDs and that kind of thing. And the one big takeaway was immutable versus immutable objects. She was doing everything as immutable objects, which we found were running into memory issues. I'm not entirely sure why. So just put everything in objects, and all of our memories just went away.
Okay. So you mean like tuples versus lists or whatnot in Python?
Yeah. We wrote our own classes for a lot of it, just because it's easier. Have like a LiDAR object and have a flight controller object. Pass the data around that way.
Yeah. I come from a C background, but more and more I'm almost always using Python, and a lot of my libraries are C++ underneath. And in fact, I've been running so much Python, now I go back to C++ and it's kind of weird. So that was disconcerting to me.
So it's funny you say that, because that's exactly what I am. I learned C++ from the very beginning. I programmed competitive robots for First Robotics in C++. And before we moved into Jetsons, a lot of our projects were Arduino based, which is also heavily C++ based. So again, a C++ background, I moved to Python. And that's this was the second real Python project I ever did. But it is just so easy to pick up coming from a C++ background.
Gotcha. Yeah. And I think before the show you were like showing us, I think you used Visual Studio Code to show us. Maybe people would be interested just to browse real quick what the code actually looks like, how you bring all this together.
For sure. Let me pull that up. Cool. So this is, you see it?
Yeah.
So we have a variety of bits of code in here. So for example, this is our navigates library. This is the one that I wrote. This is what actually has the PID objects. And you feed it the set points, and you set it up, you feed it all the gains, you tell it the radius that you want it to fly at. Cycle time, allowed error, orbit speed, all fairly simple stuff here. Hover height, hover throttle, all things that we just kind of entered. Simple things like change the radius, so you want it to fly further away, changing the orbit speed, how fast you want it to orbit, loop time, angles, some simple mapping stuff that I wrote to make stuff easier. And the actual tick function. So this is what actually takes in your current x, y, and your height, if you want it to orbit or not, and then does the math to figure out what you want it to be doing, if it should be in a mode where it's ready to fire, maps the outputs, and then outputs the PIDs directly.
So do you think this would be easy to extend to, let's say, like an outdoor scenario where, say, we were doing before the call, like James, he built a land speeder out there and you want this drone to follow along with him as like his protector or something. Do you think it would be possible to augment this code so it could follow the person in addition to just like hovering around them? Or is that something you've even already tested? But if you stepped backwards or forwards, would it actually follow you around?
So I don't know if we actually tested it, but I think there's no reason that it shouldn't be able to do it, just because all it's doing is trying to lock the drone in a position relative to the person. So if the person moves, the drone says, oh, it thinks that it got closer to the person, so it needs to back up.
Okay. So it does take translation into account.
Yeah, there's no reason why it shouldn't be able to follow someone.
Okay. It looks like this is the main loop of the whole thing?
Yeah.
Cool.
Yeah, so this was what actually kind of kept track of everything. Read the S-Bus protocol. It was another bit of code we had to write.
Yeah, it's
This is what actually
pretty heavy duty.
does a lot of the bit shifting to read the S-Bus signal, which actually really at the end of the day isn't that complicated.
Did you need to use like Python threads or anything to make this all work, or?
So the way we actually did it, let me see if I can find the example. Yeah, we did have to thread it. We just had processes.
Oh, right, yeah. Because Pythons, they don't really have concurrent threads with the global
Yeah.
interpreter lock, but it does have a nice multi-processing library.
Yeah, so we just ran the other code, passed a pipe back and forth, or used a pipe and a queue for it. A pipe for, I think it was the Z, and a queue for the S bus, I think. Maybe no, I think it's a pipe for both now. And then just pass the data through it to. Yeah, it wasn't that complicated at the end of the day. It was actually easier than I expected coming from a C++ background.
Yeah. So basically, you have a process that runs the Z, gets the tracking vectors, then you pass this along to your SBus process to send those flight commands over to the controller. Is that the gist of it?
Yeah, so like in the SBus is where we actually we connect the serial in here, and we just read the channels and we just send the channels back to the main process, and then we can send the channels, the output channels back to the SBus system, and then it outputs it to the drone. Then same with the Z, if I can find it. Again, very, very simple code. We just read all this is what tracks the ID to keep track of the person. We just find the objects in it. We find the people, we look up the numbers, and then we just pass it through.
Awesome. Yeah, I mean, that's pretty easy without, you didn't really need to use all your own machine learning models and stuff, although you could have, but the Z, basically just wraps all that up for you and uses CUDA and everything.
Yeah.
And you got some kudos on the chat for your nicely written, well-commented code, even though maybe nobody will actually see this, but it's always good to see that you put a lot of care into that.
Yeah, Sophie, our co-op, wrote a lot of this like boilerplate stuff. So
you have to make a gift to yourself sometimes on those kinds of things. So when you go back, you can remember what you were doing.
Yeah, I can't take the credit for this code. The navigation code was mine, and then the kind of main loop, all the more of that integration was mine. You can tell what code I wrote versus what code she wrote. Very obvious based on what has comments or not.
Yeah. Either way, it looks great. And do you have any future plans for this drone? Using it on another video or anything else you could use it for, maybe?
Sadly, the plans for this guy is for it to be taken apart.
Do you have so we had a couple minutes of the drone. Do you have some behind the scenes of the drone when you're building it or anything like that? Some video of that?
Maybe I have some clips here of it being assembled. So I'll pull those up.
How many of these did you build for your videos?
So we built one of these, but it got built multiple times.
Right.
So this is, can you hear it all the time? So this was the kind of animation we put together, how it goes together. So that's our water jet cutter. So they're actually water jet cutting the frame.
Nice.
And then the final assembly. So the funny part, so this assembly, amazing sequence, took a while to film, but afterwards we still had to pull the whole thing apart again to make some final changes, replace some components, add thread locker. So if you see something in the video, it's often not the real time that we're doing it.
How many times did you build this thing?
So this would have been like the second, so this shot right here would have been the second time we're putting it together after we kind of made sure everything fits. We didn't fully wire everything up, but we made it good enough that it went together fairly quickly. Assembled it this time, and then had to pull apart and assemble it one more time. So this full drone was assembled 3 times.
Yeah. Oh, it's very professional. I would not say at all this is like hacked together willy-nilly.
Yeah,
You should see my
right.
project, man. It's
The name is a little misleading, isn't it?
Yeah, well, that's what we were. So very, very pretty drone. I was happy with it.
awesome. Well, we have about 10 minutes left, and I know, Ben, this was your most recent project that was using the Jetson and that Z camera, but I believe you mentioned you actually had a previous project that kind of got you started with computer vision and the Jetson. Would you be able to tell us and show us a little bit about that too?
Yeah, so the first Jetson project that I ever did would have been our Predator helmet. So we were trying to replicate the movie Predator.
Where he has that it's basically like infrared vision, right?
It is. It's multispectral. Is the fancy way of saying it.
Multi-spray.
So that was the first project I did at the beginning of my current co-op. That would have been almost a year ago at this point. And it was a Jetson Xavier NX. Not the same one as this one, another one. Just standard is the no IR camera. So the one without the IR filter, and the standard camera. And then for the no IR camera, we actually put a visual light blocking filter on it. So it was just IR spectrums that it saw. So we cut it out. We put a 940 nanometer cutoff on it. So I think we saw from 940 to, I think that camera's around 1200 nanometers of light. And then we had our standard camera for, I'm actually not sure what its full range was. And then it was a FLIR shortwave infrared camera, so a thermal camera.
Wow.
The final.
Okay. So did I get that right? There were 3 cameras, or were there 2?
Three cameras.
3. Okay.
And then we had some modes where we could overlay thermal over regular. We could overlay the infrared over the regular. We could overlay thermal over the infrared. And then we actually put infrared blasters in the helmet as well, so it got full night vision.
Wow. And
What
type of fusion, computer vision algorithm or otherwise, did you use to fuse all those cameras together?
Again, following in the theme of how we always do things, quick and easy. So we mounted cameras very close to each other, as close as we could. We tried to use the same field of view lenses for everything. And then just simple linear cropping and overlaying it with just standard, just changing the opacity.
How
Cool.
big is this helmet? If it's got the Jetson and all these cameras and.
So the Jetson and the power system were in a backpack.
Okay.
But the helmet, it was actually a motorcycle helmet that was made to look like the Predator helmet. I actually have video of it, so let me pull it up.
And you guys seem to have a thing for these helmets. I think you also did like a Tony Stark helmet or something like that.
We did an Iron Man one, yeah. And then we've been kind of working on a Halo one for a while too. Do you have audio? Did I forget to click that button?
Yeah, I think it doesn't have audio. That's okay though if you want to talk over it.
So this is just some of my previous projects. And so that's actually some clips just from the movie. So those are some of the cameras that we used. So there's some of the products. So the Jetson, the FLIR camera, a set of Zeiss Cinemizer goggles, and then the Raspberry Pi cameras. Went over all the spectrums that it was. That's just standard thermal camera stuff. The assembly, that was the thermal camera module that we used. It's a FLIR Lepton. Writing the code.
So essentially you nice hacker scene there. So essentially you're mounting those
we can really type.
Those VR goggles inside the helmet, passing the camera video. So you don't really see outside the helmet at all yourself.
Not at all.
It's all redisplayed. Wow.
So right now you can actually see this is what it is. That's the camera's view, and then you hit the button and it transitions. So that would have been the IR camera. That was thermal. That was before I kind of lined up the overlays, but in the end I got them more lined up when everything was rigidly mounted. You can see, actually that was a fun scene because you can see that our roof is very hot. This was before we had proper insulation in the roof, and it was very hot upstairs. So we saw like 35 degrees Celsius on some days. And that was actually what helped us diagnose the fact that it was so hot upstairs. Just thermal camera. So that was, where's the shot? That was all 3 of our cameras mounted side by side. So we have our standard camera, the no IR, and then the FLIR Lepton thermal camera. So this was a cool project. It wasn't incredibly complicated, but it was a cool use of the technology of the Jetson that had just come out. And that was when we added the sounds and all the animations.
Can you skip ahead to where it shows like the actual helmet, or I remember there being like a cool visualization?
That actually might have been in the second video. So that was the helmet assembled with the control system. So the camera's mounted in the helmet. So it's actually not that big. There's just James kind of going around. So this is a little fun scene to shoot. Dramatic music.
He does a lot of stalking in his videos, I've noticed.
It's easy to script and shoot. Yeah. So this is just him actually going around using the helmet. You can see it does work.
Yeah. It looks just like the movie too. So did you notice any like lag issues with like how did you get good frame rate out of this? Somebody was asking in the chat.
It wasn't amazing, but it was good enough to walk around. Like he could walk around with the field of view that we had with the lag. I think we looked and there was about 50 milliseconds of lag, which isn't terrible.
No, I think a lot of it has to do with the synchronization of 3 separate cameras, and you're always waiting on some new camera to come in, and so yeah, that's pretty good. 50 millisecond glass to glass.
Yeah. So we didn't for this. We never. So the thermal camera, because we don't have access to like military resources, our thermal camera was limited to 9 hertz.
Oh right, yeah.
And it was only 320 by 240. So the thermal overlay was always going to be delayed.
Yeah.
But we often didn't do much overlaying. We didn't use the overlaying of the IR and the regular vision camera.
I gotcha. Yeah, those FLIRs are expensive, but they are super cool. So
They are.
They've been so hard to get for the last year or two.
Yeah. We actually had to pull apart a FLIR smartphone module to get the sensor itself.
Oh, that's smart. Yeah, because those are very affordable. But
They are.
And I think you said you have the little board that it interfaces with. I'll have to check that out.
And in those camera modules, it's literally just their sensor socketed and everything.
Interesting.
So there's a clip in the video of I just pull apart one of those modules and just took the sensor out of it.
I'm sure they would love to see that. All right. Well, we're basically at the top of the hour. Any closing questions for you guys, Dana, Jim?
Oh, I just think it's the coolest thing. So I'm glad somebody's out there trying to make reality out of all these sci-fi wave your hand things.
It's a lot of fun.
That was great. How long is it? What's your production schedule like?
So we put out a week, give or take. But our videos can take, we're about a month out right now, where we're producing videos that'll come out in about a month. But our videos take anywhere from like a week to a month generally to produce from start to finish.
So how many are you working on at one time?
A lot. I don't have a count, and I'm being honest, I've never really tried to count.
So we should
Because
just keep
awesome.
we should just keep watching your channel and watch them as they come, right?
Basically,
That's
yeah.
right.
And so to find that, we just look up Hackster on YouTube and we'll find it.
Yeah, the Hacksmith.
The Hacksmith. Okay.
Yeah, that's really commendable because I know like when I get really deep into a technical project, you kind of like to stay with one project. So being able to multiplex like that is a really valuable skill to have. All right.
Yeah.
Cool. Well, thank you so much, Ben. It was really great seeing all the awesome stuff that you've built there and all your experiences, and the videos that you make are just so incredible. What you guys are doing over there. So look forward to seeing what you guys come out with in the future. And yeah,
Thanks so
again
much.
for
That
joining
was
us.
great, man.
Thanks for having me on.
Appreciate your
All right.
time.
All right. Thanks, everybody. We will see you again next month on Jetson AI Labs. Thanks again to Ben for joining us today. That was great. Thanks, Ben.
My pleasure.
Thank you.
All right. See you guys.
Bye.